All right, so this is our lesson on graphing quadratics in all three forms. So we have the beginning of this is stating what all of our forms are and then things that you need to know about these three forms. So first off, we have vertex form. Vertex form is where you can physically see the vertex in the equation. So that is f of x equals or y equals the a value, which can be positive or negative. That just tells you if it's facing upward or downward. And then x minus h quantity squared. Let me get there we go. X minus h quantity squared plus k. So as a reminder, your vertex is hk. Since there's a minus in this equation, you take the opposite of whatever you're looking at there. So opposite of that, whatever that is, that's your vertex. And then you're going to use transformations to graph it. So you graph the vertex, which is using your transformations, and then we know how to do what we're doing with that. We can write a rule, whatever. Standard form is also called expanded form. Expanded form. Okay. That's when it is in the form y equals ax squared plus bx plus c. To rewrite in vertex form, if it's easy. We know it's easy if the lead coefficient is 1, or if b is an even number with that, along with that. If it's not, then we can find the axis of symmetry using x equals the opposite of b over 2 times a. Those of us that like to check answers, that is also what you can do. Is you'll hear me say like, or you can do this, or you can do this, or you can do this a lot in this video. And it's basically saying, hey, if you know you can do it this way, or this way, why don't you just check all of the ways once you finish? Okay. Also, to find the y value of the vertex, you're taking that x value that you got and plugging it in. So as a reminder, it is the opposite of b over 2 times a comma, and then f of whatever you get when you plug that in. Also, you're asked for the axis of symmetry, and to get the x value of the axis of the symmetry, it's the opposite of b over 2 times a. Intercept form is f of x equals, and this can have an a value in front of it, and it can be positive or negative also, but it's x minus the x-intercept times x minus the intercept. You plot the x-intercepts by setting each factor equal to 0 and solve, and then writing the x-intercept as ordered pairs. To get the vertex, you take an average of the x-intercept values because it's directly in the middle. So if it was -3 and +3, 0 is directly in the middle, which is just an average. And then to find the y value, you plug that back in. And this was all in the first video, but it's just restating everything there. Okay, so let's go ahead and go through all this practice now. So it says, write each quadratic in standard form. Remember, standard form is just expanded form, so we just have to expand it or multiply it out. X times 2x is 2x squared. I'm going to do outer and inner also and add them in my head. So we have -8x and positive x, which is -7x, and then -4 times 1, which is -4. So there is going from vertex form to standard form. This here, sorry, that was intercept form to standard form. So this one here, we are going from vertex form to standard form, and we're going to expand it, right? It's the expanded form. So I'm going to multiply x plus 2 times x plus 2. If you need to write it off to the side or within the problem, that's absolutely fine. But we have y equals 3 times the quantity of, and then multiplying this out, we get x squared plus 4x plus 4. And then plus 4, don't forget that. And then this is still not an expanded form yet this is still not standard form yet. I got to distribute my 3 and then combine the 4 with its like term. So we have 3x squared plus 12x plus 12 plus 4. So then our final answer is y equals 3x squared plus 12x plus 16. Okay. All right, next we'll do some graphing. So you'll hear a lot of, or you can do this, or you can do this from me. So just keep that in mind. If you don't know how to do it one way, you can do it another way. All right, so what form is this? This is intercept form or factored form, but we're calling it intercept form. And the reason we call it intercept form because you can easily find your x-intercepts. You find your x-intercepts by setting each factor equal to 0 and solve. So we have x plus 3 equals 0, and we get x equals -3. And we have x minus 3 equals 0, and we get x equals +3. So our x-intercepts, remember, intercepts are ordered pairs, are -3, 0 and +3, 0. And we can graph as we go, or we can graph when we're done. I think it's smart to graph as we go because then you can see what you have. So those are 2 points on my parabola. I need to find my axis of symmetry. My axis of symmetry is directly in between those 2 points. I graphed it wrong. Here we go, graph as you go. My axis of symmetry is directly in between these 2 points. So my axis of symmetry is the dashed line. Remember, it's not a part of the parabola. That goes on forever and ever and ever, so arrows on the end. It goes directly in between those two, so that's x equals 0. Algebraically, you can find that by doing -3 plus 3, so these two added up, and then dividing that by 2. 0 divided by 2 is 0. My vertex is directly in between those 2 points, so it's 0 comma something. So you are going to find f of 0 to get that value. So f of 0 is 0 plus 3 is 3, times 0 minus 3 is -3, which is -9. So 0, -9 is my vertex. My y-intercept is always 0 comma something, and you find f of 0, which we already did, which is -9. So my y-intercept is 0, -9. And my vertex is also 0, -9. All right, my zeros, I already did the work for. The zeros are always in the form x equals, and that was x equals -3 and x equals +3. All right, now we can graph this parabola. We have enough points to graph the parabola. You need 3 points, including the vertex, to graph a parabola. Domain, if you look left to right, your domain is all real numbers, -infinity to +infinity. You could also get that from the equation because there's no restrictions. My range, the lowest my y values go are -9, and there is a value there, and they go forever, so infinitely. Where is it increasing? So that, remember, that's where you look left to right and the graph is going uphill. So that's right here. So that's from 0 infinitely. And remember, we always use parentheses on increasing and decreasing. And then it's decreasing. Let me hit my highlighter back again. If you look left to right, it's when it's going downhill. So that's from -infinity to 0. Remember, you're stating the domain of that piece. Good? Okay, let's move on to the next one here. So the next one is in standard form, which looks like it's expanded. Now, we can get these things in any order that we want. We can do x-intercepts next. We can do axis of symmetry next. We can do vertex next. I'm going to do axis of symmetry next. The reason I'm not doing my x-intercepts next is because this is not in intercept form. So I can't just look at it and see what it is. So I'm going to do my axis of symmetry next, or my y-intercept next, because I can look at it and see my y-intercept. My y-intercept is 0, -5. It's 0 comma c. My vertex and my axis of symmetry is what I'm going to do next. So I can get my vertex by doing, my axis of symmetry by doing x equals the opposite of the b value, which is -4, over 2 times the a value, which is 1. Simplify that. -4 divided by 2 is -2. So my axis of symmetry is x equals -2. That means my vertex is -2 comma something. So I'm going to find f of -2 to get that y value. -2 squared plus 4 times -2 minus 5. So that is 4 minus 8 minus 5. 4 minus 8 is -4. -4 minus 5 is -9. So my vertex is -2, -9. I'm going to graph what I have so far. -2, -9, right there. My axis of symmetry is going through that, so I'm going to put a dashed line going through that. My y-intercept is 0, -5. Also, since the graph is symmetric, I know that I have a point on the same side of the axis, or sorry, on the opposite side of the axis of symmetry in the same spot, so right here. So I also know I have a point at -4, -5, which is enough to graph, but I'm also asked for my x-intercepts and my zeros, so I want to get those accurate before I graph. So let's go to x-intercepts and zeros. So if this was an intercept form, life would be a lot easier. So let's get it intercept form if possible, right? So that we can see what our intercepts are. So to get it intercept form means we need to factor it. So I'm looking for two numbers that multiply to give me -5 and add to give me 4. So that is x plus 5 times x minus 1. So it is factorable. Therefore, I can find my x-intercepts very easily. I can always find them, but very easily here. So set each factor equal to 0 and solve. I get x equals -5 and x equals +1 for my zeros. So my x-intercepts are -5, 0 and 1, 0. I'm going to graph those. -5, 0 and 1, 0. I'm going to go ahead and graph this parabola now. It's a little bit more accurate than it would be if I just graphed it with those other 3 points. And then also I'm going to do my domain. My domain on parabolas are all real numbers. My range, the lowest my y values go are -9, and then they go forever. Increasing on, so if you look right here, it's increasing from here forever. So that's from -2 to infinity. Decreasing from -infinity to -2. Okay. All right, let's move on to the next one here. So this, once again, is in standard form. So I'm going to do it in the same order that I did the other one. Oh, let's actually go back to the other one. So for this vertex, I could have immediately factored it, right? I could have immediately factored it, got -5, 0, 1, 0. And then I could have said to get my axis of symmetry, it's right in the middle of these two. So I can add those two and divide by 2. -4 divided by 2 is -2. I could have done that, okay? But if it didn't ask me for the x-intercepts, then I wouldn't have to do that. All right, so I'm going to do this one the same way I did the other one. I'm going to start by saying I can find the y-intercept. That's easy, 0, 2. And I'll graph that, 0, 2. All right, next I'm going to do the axis of symmetry and the vertex. So axis of symmetry is x equals, and then it's the opposite of b, so -6, over 2 times a, which is 1, so that's -3. So the axis of symmetry is x equals -3. The vertex is -3, something. So I'm going to find f of -3, or plug -3 into the function. And they're called y, but I'm still going to write it like that. I don't care. So I have -3 squared plus 6 times -3 plus 2. 9 minus 18 plus 2 is -7. So -3, -7, okay? And that's for my vertex. All right, so I'll graph the things that I have, -3, -7. My axis of symmetry is going through that at x equals -3. And then I have another point that I know because I know that this graph is symmetric. So that's 3 to the right of the axis of symmetry, so 3 to the left. So you should have another point at -6 too. All right, I still want to get my zeros, okay? So I still want to get my zeros, and I'm going to see if this is factorable. So to see if this is factorable, I need 2 values that multiply to give me 2 and add to give me 6, which is not going to happen. So in order to get my x-intercept, I can either use the quadratic formula, set it equal to 0 and solve, or I can complete the square and put this in vertex form, which is what I'm going to do. And if you notice, it says right here at the top, rewrite in vertex form if easy. So let's go ahead and rewrite this in vertex form, and then we could have avoided the opposite of b over 2 times a also. Keep that in mind. All right, so we're gonna, or we can use this. We can use this to do it, right? We could say y equals x plus 3 quantity squared minus 7. There, it's in vertex form, right? I want to practice writing in vertex form from this because I feel like we should be doing that. So remember to do that. We need to complete the square for these two terms. So we're going to move the 2 over. Take half of positive 6, which is 3 squared, which is 9. Balance the equation by subtracting 9. And we get y equals x plus 3 quantity squared minus 7. So same way. All right, so to find my zeros or x-intercepts, I'm going to set y equal to 0 and solve. So I have 0 equals x plus 3 quantity squared minus 7. So it's easier to use this to find it than now, trying to use quadratic formula. So add 7 to both sides. Square root plus or minus. X plus 3 equals plus or minus root 7, and then subtract 3 from both sides. So x equals negative 3 plus or minus root 7. So those are my zeros. X equals negative 3 plus root 7, and x equals negative 3 minus root 7, which we can write like that. And then my x-intercept, same thing, negative 3 plus or minus root 7 comma 0. All right, and graphing those is not going to be wonderful, so I'm just going to go through the x-axis. Oh my gosh, that's not pretty at all. It looked like a deer's face. Okay, a little babbling to myself a little bit here. All right, so if you want to know where those are, that's like right there and right there. See? Beautiful. Okay, domain and range. So domain, all real numbers. Range, the lowest my graph goes is negative 7. And then it goes on infinitely. Increasing from negative 3 forever. Decreasing from negative infinity to negative 3. Okay, so here's the idea, here's the thought behind this. If it's in standard form, you can go to vertex form and then find the vertex and find the x-intercepts. Or if it's in standard form, you can do the opposite of b over 2 times a to find the vertex, the x value of the vertex, plug it in, and then go to vertex form. It's up to you, right? All right, last section here. Which equation would produce the graph to the right? So if you look, all 4 of these are in vertex form. So first off, let's get the vertex. Here's the vertex right here. That is, oh goodness, negative 2, positive 2. So I'm looking for an x plus 2 quantity squared plus 2. So this is out and this is out. So now I need to know, does this have an a value of 1/3 of 3? So we're going to use our other points here to help us get it. So I can see that I have a point right here and a point, oh my gosh, it's not pretty. It's a little messy. I see that I have a point right there. So when I plug in 2, I get 6. So the one way of checking is plugging in 2 and seeing which one gives you 6, okay? That's negative 1. When I plug in negative 1, I get 6. Seeing which one, when you plug in negative 1, you get 6 is one way of doing that, but it's actually supposed to be 5. I don't know. So let's try that first. If I plug in negative 1 here, I get 5. So this graph is just hideous. Is that supposed to be a 5? Oh no, maybe it's right here. That's why. This graph is not accurate. Right there. So that's right. That's what it is. Negative 1, 5. So that's it. And when I plug in negative 1 here, I get 1/3, 2 1/3, which is definitely not it, right? So that's one way of doing it. Or looking at it and saying, hey, that's narrower because the points would be here if there were no transformations. So which number of an a value gives me a narrower graph? And that would be a 3. So that was like maybe the worst problem ever, but we're gonna move along. That graph is inaccurate and ugly. I'll fix it for notes. And then finally, solve over the complex number system. So this is just a practice at solving. Pause the video, try these yourself, okay? See how you did. So this one right away, go ahead, pause it. All right, this one right away, no solution. I'm not going to even move on from this by squaring both sides because there is no number on the face of this earth. When you square root it, you get negative 8. All right, next one right here, I'm gonna start by dividing both sides by negative 3. because I'm going to solve this quadratic by square rooting. I'm not going to expand it. That is way more work. Now I'm going to solve by square rooting. Whenever I square root, I have to remember to do plus or minus to account for both the positive and negative solution. So positive and negative. And now I'll take the square root of -4, which is 2i. Add 1 to both sides, and we have x equals 1 plus or minus 2i. All right, lastly, I have another quadratic. This one I cannot solve by square rooting, so I'm gonna try to factor it. It's already equal to 0. I'm looking for two numbers that multiply to give me 14 and add to give me -12. Not gonna happen. So you can complete the square or use the quadratic formula. I'm going to complete the square. First, I'm gonna start off by dividing both sides by 2. You can use the quadratic formula if you want, just make sure you get the same answer. I have x squared minus 6x plus 7 halves equals 0. I'm going to add 7 halves, subtract 7 halves from both sides. I'm gonna complete the square for this trinomial here, or make it a trinomial by taking half of the b value, which is -3, and squaring it. That's plus 9. I'll add 9 to this side. The left-hand side factors to x minus 3 quantity squared. The right-hand side, I'll make this a fraction, and then common denominator by multiplying by 2, that becomes an 18. 18 and -7 is 11 over 2. Square root to solve. So square root plus or minus, square root plus or minus. I have x minus 3 is equal to positive or negative root 11 over root 2. I need to rationalize this, so I'm going to multiply by root 2 over root 2. I get x equals, I'm going to add 3 to both sides, plus or minus. Root 11 times root 2 is root 22. Root 2 times root 2 is 2. 3 plus or minus root 22 over 2. If you did the quadratic formula, you should have the exact same thing. If you don't, you probably didn't simplify. All right, that's it for today. You can go ahead and get started.